most prominent and beautiful part of NASA's James Webb Space Telescope is its gold primary mirror with its smaller secondary mirror suspended out in front. The Webb telescope is a reflecting telescope, technically an astigmatic telescope. This means that its concave primary mirror captures the light and reflects it to the secondary convex mirror, which reflects the light back to the concave rectangular-shaped tertiary mirror, and then, finally, to the flat fine steering mirror, which sends the light through a hole through the center of the primary mirror to focus on the science instruments behind the primary mirror. This kind of telescope enables a wider field of view and minimizes optical distortion. The primary and secondary mirror form what is called a passive ray telescope, similar to the Hubble Space Telescope. It's this third powered mirror that makes Webb an astigmatic telescope. Webb has the largest primary mirror ever to fly in space. At 21 feet and 3 inches across, or 6.5 meters, it's filled to see the faintest light coming from the most distant luminous objects in the universe. Its size presents one of the biggest mission challenges. The primary mirror is larger than the fairing of the rocket lifting it into space, so Webb's mirrors has to be segmented and folded for launch, and that means it has to be unfolded and focused in space. Webb's mirrors are made out of a rare metal called beryllium. Because this chemical element is very strong, lightweight, and virtually ceases changing shape when it gets really cold. Starting from beryllium mines in Utah, the mirrors crisscrossed the country. The beryllium was made into a powder of microscopic spheres, then fused by intense pressure into solid discs that were machined and polished. Lastly, the mirror segments were coated with a thin layer of pure gold, less than 100 atoms thick, to best reflect infrared light. All of the mirror machining and polishing was done at room temperature. Because beryllium changes its shape with temperature and only becomes stable at very cold temperatures, the mirrors were manufactured to precisely the wrong prescription at room temperature, so that they have precisely the right shape at operating temperatures. That's negative 388 degrees Fahrenheit, or negative 233 degrees Celsius. That's colder than the surface of Pluto. A robot-like system perfectly mounted each mirror onto Webb's composite backplane structure. Behind each mirror is an actuator system that can move each mirror segment precisely in every direction, as well as modify each segment's shape ever so slightly, so that all 18 segments can be aligned to form a single perfect mirror. After Webb is deployed, it takes several months for the instruments to cool to their operating temperature. During this time, engineers on the ground will use Webb's near-infrared camera and a process called Wavefront Sensing Control to align Webb's mirrors. The mirrors will be retuned as needed during the mission to maintain Webb's perfect vision. Once Webb launches and the science team aligns those extraordinary mirrors, a new scientific era will begin.